Mars is small, cold, and supposedly dead inside. Its core should have frozen solid billions of years ago. In 2018, NASA sent a lander that couldn't drive, couldn't dig, couldn't move at all, and told it to just sit still and listen. Listening shouldn't have worked. It did. And what it heard confirmed something was still moving down there. The mission nobody expected to succeed. In May 2018, NASA launched a lander called InSight from Vandenberg Air Force Base in California. It was the first interplanetary mission ever launched from the west coast of the United States. The full name was a mouthful: Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport. Nobody called it that. Everyone just called it InSight. The mission cost the United States about $814 million, with France and Germany adding roughly another $180 million for the seismometer and heat probe. That is a fraction of what a single Apollo moon mission cost, spent on a machine that would never move, never drive, never take a single step across the surface. InSight landed on November 26, 2018, in a flat plain near the Martian equator called Elysium Planitia. NASA picked that spot for one reason only. It was boring, flat, smooth, almost no rocks. Not because scientists wanted to study the surface there, but because a boring landing site meant the lander wouldn't tip over or get shredded coming down. The whole point of InSight was never the ground under it. The point was everything underneath that ground. The lander was only supposed to work for about 2 years. It ended up running for more than 4, all the way until December 2022. And that extra time turned out to matter enormously for what scientists eventually found. That long stretch of quiet listening is where the real story starts, because what InSight was built to detect had never once been directly measured on Mars before. The machine that listened for tremors in sight carried a single main tool that mattered most: a seismometer, a device built to sense the faintest shaking passing through the ground. On Earth, seismometers detect earthquakes. On Mars, they detect what scientists call Marsquakes. Mars does not have moving tectonic plates like Earth does, so its quakes come from a different source, mostly cooling rock cracking and shifting deep underground. Scientists expected some quakes. What they did not expect was how many. Over its 4-year run, InSight detected more than 1,300 Marsquakes, far more than most researchers had guessed a supposedly quiet, geologically dead planet would ever produce. Each quake sends waves rippling through the planet, and those waves change speed and direction depending on what they pass through: solid rock, liquid rock, or metal. By timing how long those waves took to bounce around inside Mars, and by watching which ones disappeared entirely because something blocked them, scientists could start mapping the inside of the planet for the first time in human history, without ever drilling a single hole. InSight also carried a second instrument, a heat probe nicknamed the Mole, designed to hammer itself about 5 meters into the Martian soil, to measure how much warmth was escaping from underground. That part of the mission ran into trouble almost immediately. The soil at the landing site clumped together in a way engineers had not planned for, and the mole never managed to bury itself more than about 40 centimeters down before the team gave up on it. The seismometer, though, worked exactly as hoped, and it ended up carrying almost the entire mission on its own. That mapping effort became one of the most important scientific results of the entire mission. And the very first thing it revealed was something about the very center of the planet that upended older assumptions almost immediately. The core that didn't match the models. Before InSight, scientists had only guessed at the size of Mars's core using computer models and comparisons to Earth. Actually measuring it required seismic waves passing directly through the planet's middle. the same method used to measure Earth's core more than a century ago, and the Moon's core more recently. In 2021, using data from Marsquakes, InSight's science team calculated the width of Mars's core for the very first time. Their estimate, somewhere between about 2,230 and 2,320 miles across. That made the core noticeably bigger than most earlier models had predicted, and it confirmed something else researchers had long suspected but never proven. The core is liquid, not solid, at least on the outside. That alone would have been a major discovery. Mars became only the third body in the solar system, after Earth and the Moon, to have its core directly measured with seismic data instead of guesswork. To put the size in perspective, Mars itself is only about half the diameter of Earth, yet its core takes up close to half of the planet's total radius. A far larger share than Earth's core takes up inside our own planet. That single ratio told scientists the core had to be made of lighter material than pure iron. Since a denser core that size would have made the whole planet weigh more than it actually does. But the story didn't stop there, because a second, more detailed study using additional Marsquakes soon complicated the picture even further. By 2023, a fresh look at the data suggested the core wasn't quite what the first estimate showed. It was smaller than that early number and denser, and it came wrapped in something nobody had accounted for in the original models. The layer nobody saw coming. A team at ETH Zurich went back through years of InSight seismic data and noticed something ODD. The zone they had originally labeled as the outer edge of the liquid core did not behave the way liquid iron should behave. It behaved more like melted rock. What they found was a layer of molten silicate rock, essentially liquid magma, sitting on top of the actual metal core, roughly 150 kilometers thick. Once that layer was properly separated from the core itself in the models, the true metal core turned out to be smaller and denser than the 2021 estimate had suggested. In plain terms, earlier scientists had accidentally been measuring part of the mantle and mistaking it for the outer core. It is a bit like trying to measure someone's actual height while they are wearing several inches of extra padding you did not know was there. Once the padding was accounted for, the real number changed. This corrected picture, published in 2023, gave scientists their clearest look yet at what Mars is actually made of on the inside. But even that was not the final word. 2 years later, an even deeper mystery hiding inside that same core would finally get solved. The discovery hiding inside the discovery. For years, the working assumption was that Mars's core was liquid all the way through, with no solid center at all, unlike Earth, which has a solid inner core surrounded by a liquid outer layer. That difference was thought to be one of the reasons Mars and Earth turned out so differently. Then in 2025, a research team went back through the Marsquake data one more time and found something that had been missed before. Seismic waves that had clearly bounced off a solid boundary buried deep within what everyone had assumed was pure liquid. Multiple different types of waves all pointed to the same conclusion. Mars has a solid inner core, roughly 600 kilometers across, sitting inside a liquid outer core, structured almost exactly like the inside of Earth. Nobody had confirmed this before, because the signal was faint and easy to miss unless you knew exactly where to look. The extra 2 years InSight ran past its original mission length turned out to be the reason there was enough data to finally catch it. Before we move on, if you're enjoying this analysis, please consider subscribing. It helps the channel tremendously. That solid center matters for a much bigger reason than just planetary trivia, because on Earth, the boundary between a solid inner core and a liquid outer core is the exact engine that powers our planet's magnetic field. And Mars, as everyone already knows, doesn't have one anymore. the magnetic field that vanished. Mars has almost no global magnetic field today. Only faint, patchy traces of magnetism remain locked into old crust in a few places, leftover fingerprints of something that used to be much bigger. Billions of years ago, though, evidence suggests Mars did have a real planet-wide magnetic field, generated the same way Earth's is, by molten metal moving around inside its core. Then, sometime between roughly 4.2 and 3.7 billion years ago, that internal engine, called a dynamo, shut down. Once it did, Mars lost its magnetic shield, the same kind of shield that protects Earth's atmosphere from being blasted away by the sun. Without that shield, the sun's solar wind went to work on the Martian atmosphere directly. NASA's separate MAVEN spacecraft, which has orbited Mars since 2014, actually caught this process happening in real time, watching charged particles from the sun physically knock gas molecules out of the upper atmosphere and off into space, a process scientists call sputtering. It works something like slow-motion sandblasting, where each individual collision only knocks away a small number of molecules, but billions of years of that same collision happening over and over eventually adds up to almost the entire atmosphere. MAVEN's data also showed that the rate of this stripping jumps sharply whenever a solar storm hits, meaning the damage wasn't spread out evenly over time, but likely came in intense bursts. Over billions of years, that slow, steady loss stripped away most of the thick atmosphere Mars once had, and with it went the pressure and warmth needed to keep liquid water sitting on the surface. The discovery of a solid inner core inside Mars now gives scientists a much better reference point for understanding exactly how that ancient dynamo worked before it died, and why a planet Mars's size couldn't keep it running the way Earth has. But the seismic data revealed one more thing that nobody expected from a planet that was supposed to be geologically finished: the heat that shouldn't still be there. If Mars's insides were completely cold and still, none of this shaking would even be happening. But InSight kept detecting quakes clustered heavily around one specific region, a network of cracks called Cerberus Fossae, stretching more than 800 miles across a plain called Elysium Planitia, not far from where InSight itself was sitting. More than half of all the Marsquakes InSight ever detected came from that one area. The quakes had a low-frequency signature that scientists associate with warm, possibly molten material shifting underground, roughly 30 to 50 kilometers beneath the surface. Around the same time, separate researchers studying orbital images found dark, volcanic-looking deposits scattered around Cerberus Fossae that, based on crater counting, appeared to be only around 50,000 years old, practically yesterday by geological standards. Put together, both lines of evidence point the same direction. There is likely still a pocket of magma sitting underneath that region today, and Mars may still be volcanically active, quietly, deep underground, even though nobody has ever seen an eruption reach the surface in recorded history. Some researchers have suggested this could even matter for the search for life, since underground heat and moisture together are exactly the kind of environment life might be able to survive in. A planet that was supposed to have gone fully cold and quiet billions of years ago is apparently still simmering underneath. And that single fact forces scientists to rethink what geologically dead even means for a rocky planet like Mars. Why nobody caught any of this sooner? None of this was visible from orbit, and none of it showed up in decades of rover photos crawling across the surface. Spirit, Opportunity, Curiosity, and Perseverance all studied rocks and soil sitting right on top of the ground, useful for understanding the planet's surface history, but useless for peering into its center. Orbiters like MAVEN and earlier missions mapped weather, magnetism, and gravity from high above. giving scientists a global view of the outside of Mars without ever answering what was happening far beneath their instruments. Even earlier attempts to place a seismometer on Mars had failed decades before InSight ever launched, leaving the interior of the planet almost completely unknown territory well into the 21st century. But nothing before InSight had a way to physically feel what was happening thousands of miles straight down. It took a stationary lander, sitting perfectly still in one boring flat spot for 4 years, patiently recording every faint tremor that passed beneath it, to finally answer questions about Mars's insides that spacecraft and rovers simply weren't built to answer. The seismometer never moved an inch its entire mission, and that stillness is exactly what made it possible to hear signals no moving vehicle ever could have picked up cleanly. It's a strange kind of discovery, made not by traveling further, but by finally sitting still long enough to listen properly. The verdict: Mars looks like a dead planet from the outside, and in most ways it is. No breathable air, no rivers, no global magnetic shield left standing. But underneath all that stillness, NASA found a planet still quietly working. A layered core with a solid heart wrapped inside a liquid shell. A hidden pocket of molten rock nobody expected to survive this long. And quakes still shaking loose from underground heat billions of years after most scientists assumed the planet had gone completely cold. The magnetic field that once protected Mars died a long time ago, and that single event set off the slow collapse of its entire atmosphere and its water. But the core that powered that field, it turns out, never fully finished cooling. Mars didn't go quiet because everything inside it stopped. It went quiet because whatever is still happening down there has been happening far below anyone's ability to see it, until a single patient lander finally sat down and listened. If you enjoyed this video, make sure to subscribe, and I'll see you in the next one.